Okay, welcome everybody for our weekly seminar series at the Department of Marine Geosciences. And today we're hosting one of our previous postdocs who was doing his postdoc here at the University of Haifa and just recently moved to University of Texas at Austin. And is going to talk about a lake that existed here in Israel long time ago. But I leave you the podium for presenting yourself. What is your background, and then feel free to start the talk. Thank you.
Hi, hello. Hello, good afternoon, everyone. Here it's just good morning. So my name is Mohd Danish, and actually I did my bachelor and master degree in geology from Aligarh Muslim University. Then I did my PhD from ISER Pune, where I worked on this biogeochemical cycling of the trace metals. Then before moving to the University of Haifa, I was working in Hebrew University of Jerusalem with Dr. Uri Rib and late Dr. Eyal Burgaft, who passed away last 2000 in 2023. So he was my main supervisor there. Then I moved to the University of Haifa. There I was working on this self regions of the Eastern Mediterranean Sea, and I was quantifying the early diagenetic processes in the sediments and how they impact. And with the Nicholas, I worked on this project, this Erk-el-Ahmar formation, and also the another project Cretaceous sediments, in which we are measuring currently the molybdenum isotopes in India. So just waiting for the results. So this is my short introduction, and right now I am at the University of Texas. So here I am working on the carbon cycling, particularly in the coastal regions. So yeah, this is my short introduction. Now we are going to discuss about what we have done so far in this Erk-el-Ahmar formations. So before getting into the details of the work done, I just would like to highlight why it is important to study the Pliocene, and how it will make the significance in existing understanding of Pliocene, and how it could help to understand the paleoclimatic conditions and the future climatic projections. So basically, Pliocene is supposed to be the last warmed interval, and particularly the mid-Pliocene warm period. It was believed that the CO2 concentration during that Pliocene time and the temperature was similar to that of today. So it has been well documented through the analysis of this delta 11 boron isotopes and alkalinone in the marine archives. And based on that analysis and observations, scientists have projected under the RCP 8.5 that by 2030, so global climate will resemble most of the mid-Pliocene time period. Most of the Pliocene time period. And and people believe that particularly that means there is six warm interval period during the geological history, but most likely we are going to evidence the climatic conditions as were prevailing during the Pliocene, and particularly in 2100 century. Okay. So there now I will discuss about what has been people done in Paleocenes, particularly in the terrestrial records, because whatever the studies are available, they are just focused on mainly on the marine record. but not on the terrestrial records. But there are only few studies are available on the terrestrial records. There is the reason of why we are not able to evidence the Pliocene, because there is less Pliocene record is existing. So this is the Cameroon Basin in the East Africa, and it shows that the cyclicity of the wet and dry seasons, particularly during the late Pliocene time period. And this studies has been done based on the oxygen isotopic compositions. The another studies people have done in the Kaidam Basin, in the Tibetan Plateau. So this time period is covering the time period between 2 to 4 million years, and they have analyzed the magnetic susceptibility and the halite record. So they have also found some kind of the cyclist they have found some kind of the cyclicity in their magnetic susceptibility and halite records, and they have found the precision cycles of 20 kilo a year, indicating the continuous deposition of the sediments in these regions. And precipitation and the chemical weathering in the region is due to the response to the strong precision forcing. So, Nicholas, I am getting always notifications to admit it someone. So, some other one person can do it, because I'm getting distracted for.
I am the only one doing it. You just talk.
Okay. And people they have find out the evaporation is more sensitive to eccentricity forcing. So, based on their record, it's found that the magnetic susceptibility trends resemble global ice volume records, suggested that the long-term ice volume control on precipitation in the Kaidam basins. The another study is again from this San Mencia basins. So they have also this study also involved the time period between 1.93 to 4.79 million years, and they also did this elemental concentration of the rubidium and strontium and the magnetic susceptibility. So they have also find the cyclicity of the monsoonal variations particularly, and they have associated this variation with the high intensity and low intensity of the chemical weathering in the region. They have also did this analysis of this magnetic susceptibility data and rubidium by strontium ratio, and again they found this cyclicity based on this elemental ratio of rubidium and strontium. They found three strong cyclicity of one is 405 kiloyear eccentricity, and another one is 100 kiloyear, and the obliquity is 41 kiloyear. So they have also found that the changes in the precipitations is driving the chemical weathering in the region, and that is also indicating the changing hydroclimatic conditions during the deposition of these sediments. There is only one study is available from the Eastern Mediterranean regions. So they have also identified this the eccentricity cycles in these sediments, which is deposited, belongs to this northeastern Greece regions particularly. So they also identified the eccentricity cyclicity in their sediments records. So, based on the previous observation, it is found that during the Pliocene, this orbital cyclicity is particularly controlling the deposition of the sediments and the hydroclimatic conditions also there. So this is the study area which we have, from where we have took the samples, and this is situated in the Central Jordan Valley in Israel, and this rock records has been dated by the previously by the Davis. So they found that it's the age of this is ranging from the 3.3 million years to the 4.5 million years using the 10 beryllium and 26 aluminum dating method. The same place we have also did the dating with our collaborator from the France, from the Spain. So we have also dated the same age of 3.9 million years. Uh, yeah, so the objective of our study was to establish the sedimentology and stratigraphy of the ER formations, which is also further is establishing the paleohydrology and paleohydroclimatic conditions in that regions. Particularly, there are a lot of studies has been available, but in this Pliocene period, there is no studies available, and people have studied the how the Kinneret Basin's hydroclimatic conditions has been evolved. But because this is not completely understood since the Miocene, because of there is gap between of less understanding of this Pliocene time record. So of course, understanding this will help to understand the whole evolution of the hydroclimatic conditions in the regions. So considering that, we have done the samplings there. In the several times in the Erk-el-Ahmar Formation. So this is the southern outcrop, and you can see how tall is this. So it took very tough efforts to collect the samples. So they collected they fix a rope, and from that rope they collected the samples, particularly Nicholas and one of his PhD, his master students. I was not the part of this field, and they did this three core samplings from this place only, the southern outcrops only. So we have this southern outcrop, we have this northern outcrop, and we have this middle gully. So these are the exposed sections where we can easily collect the samples, not the easily, but up to the only to above 30 to 30 meter only. And here we can just collect samples from 5 to 10 meter only from this northern sector. So this is very small outcrop here, only 2 to 3 5 meter 2 to 3 meter only the sample sediments are exposed. So this is the cross-sectional view of this of the sections. So if you see, this is the southern outcrop back behind the picture, and this the north outcrop. The height of this from the erosional surface is 40 meter, and height of this is from the erosional surface is 30 meter, and this is deposit. This is covered by the talus. Below of this northern outcrop, and similarly with the for the southern outcrop. And here you cannot see the middle gully, but in this cross sectional view you can see this how this middle gully is lying. So if you see this cross sectional view and the stratigraphy of this sedimentary layers, you will find that the northern outcrop layers are dipping under the underneath of the southern outcrop. Yeah, and the lithology of this region is mostly clastic sediments we are getting, but occasionally we were getting the this evaporites layer of 1 centimeter, and some kind of the gypsums, and some kind of carbonates nodules also, carbonate concretions are also there. So the first thing is we attempt to make the lithostratigraphic correlation between the outcrops. So as I told previously that it was very difficult to make the correlation between the outcrops, exposed outcrops, because of the tectonic activity which makes the tilted northern outcrop underneath of the southern outcrop. So we were not able to correlate. We were not able to correlate the north outcrop with the south outcrop. But when we see this sedimentology, so the mostly are comprised by the this clastic sediments, and this is the age dated. This is the age dated by the Davis for the southern outcrop and for the northern outcrop. So our age is also the same as they have dated, lying between their range. Yeah, so this is the core. We have taken 3 cores from the southern outcrop, particularly, which is ERK3, ERK2, and ERK4 along the deep directions, so that we can get as long as the or we can get high time record from these regions. So so we have then again did the correlations between the outcrops between the cores and cores with the outcrop, particularly from the southern outcrop. So we have found around this record around if we compile this record, so it is going beyond the 50 meters of thickness totally, and the upper layer of the ERK4 is matching with the down layer of the southern outcrop. So uh, we have found the sediment composition of these sediments is we have found the clastic sediment, but in the clastic sediments we got mostly the quartz and the calcites. There are some gypsum minerals also there, but mostly we found the quartz and calcite, and also there is some clay minerals, but we were not able to identify what kind of the clay minerals are there, whether it is elite, kaolinite, and all those things. In these sediments, we have also found this fish tooth and the osteocoats, and also we found some bones and plants and forum. And so by indicating the forum, because it's supposed to be the freshwater lake strand system, but we are speculating that this forum could be derived from the catchment area, or because this area is has multiple kind of the lithology, which could also supply, and also it could be windborne forums samples there in this formation sediments. So the grain size of we have done the grain size analysis of both our outcrop and this core samples, and we have found that the grain size, so the multi-dimensional distributions means which is suggesting that there is not one source only for the sediments in the Erk-el-Ahmar formations, but there is multiple sediment sources are working, which are contributing the sedimentary part of this Erk-el-Ahmar formations. Though, so according to the Volk and Folk classification, most of the sediments they are classified as the silt-rich sediments of the Erk-el-Ahmar formation. So based on the previous observations, then we try to unmixing the sources. What are the possible sources of the sediments? Then we have found the 4 possible end members. So one end members is we included to the riverine deposits, and seconds to the wind, to the sorry to the wind, and most of the sediments are deposited there that are from the transportations, and the second from the wind, and third from the tectonic activity, means sometimes because it's a tectonically active area, so sometimes tectonic activity could enhance the sedimentation in the region. So the third one is that tectonic activity. Fourth one is because its abundance is very less, so it is very difficult to assign what kind of the means processes could supply for that. So then this sediments grain size we have plotted in this model of this CM diagram. So basically it is between the coarse 99 percentile and median 50 percentile of this is the diameter of the this is the distribution of the grain size based on the grain size analysis, and we have found that most of the samples has been deposited in the suspension suspension regions means the energy condition was not that much when the sediments were depositing, but occasionally we have found that some of the sediments has been deposited in high energy conditions, and there is we speculate that there is some of the sediments has been deposited into the aeolian suspense through the aeolian suspense. So this CM diagram and in the observation we have observed in the grain size distribution and the end member mixing modeling, it is suggesting that these sediments has been deposited in a lacustrine environment, particularly through the riverine fluxes and through the suspension in the water column. So of these sediments, we have also did this geochemical analysis. We did both geochemical analysis of quantitative and semi-quantitative analysis. Here I'm just presenting the semi-quantitative analysis because I just received this quantitative analysis in last week, so I have not evaluated those things. So based on this geochemistry data, we are able to identify, and based on this geochemistry data and the magnetic susceptibility and the lithology, we are able to identify the 7 units in this two out two core sections, particularly ERK2 and ERK3, and we are getting the variability in this elemental concentrations that is showing there is the changes in the hydroclimatic conditions in the regions and change in the weathering conditions. Particularly if we see this titanium element which is very resist to alteration when it is involving in the chemical weathering processes. We have found that it is quite well showing the cyclicity. For example, the concentration of this titanium is increasing in the upper layer, then it's again decreasing, then again increasing. So this cyclicity is showing that there is some kind of the cyclicity might also preserving in these sediments of the Erk-el-Ahmar formations. So yeah, that is the next task we are planning to do in these sediments, applying the spectral analysis for this magnetic susceptibility data and for this elemental data to see whether there is any cyclicity like the cyclicity existing within the existing studies which I showed you earlier. So we have done this PCA analysis and we have found for kind of we have found this that these elements, particularly aluminum and silicon, they are falling in inward quadrant, and aluminum of calcium and chlorine, they are falling in another, and titanium, magnesium, iron, potassium, they are falling in another quadrant. So basically, we are based on this PC analysis, we are able to identify that there is possibility. There are there are particularly 2 processes which are contributing this geochemical signature of the sediments. One is this allochthonous and another one is the autochthonous. So allochthonous, mostly we are collaborating this manganese, iron, potassium. They are mostly causing their concentration is changing due to the autochthonous processes, because manganese and iron, they involve in the redox conditions, and aluminum and silicon, because this is mostly terrestrial derived elements, so their concentration varying in the sediments through the terrestrial deposits only. And calcium, again, it could be influenced by the early diagenesis processes, and also it could be influenced by the evaporation, and also it could be influenced by the precipitation and dissolution of the carbonates minerals. So we put this calcium is indicator of this dry conditions, and aluminum by silicon, it's for the wet conditions particularly, and magnesium and iron, this is changing through the autochthonous deposits, particularly during the early diagenesis or developing or due to the development of the anoxic conditions during the deposition composition of the sediments. So based on these observations, we have found that the aluminum, silica, potassium, titanium, magnesium, and iron represent allochthonous material. They stand as a reliable indicator of weathering. The surrounding basalt rocks, which is also during the phases of the increased precipitations. Calcium, sulfur, and chlorine, they are the orthogenic material, but we don't neglect that calcium, sulfur, they cannot supply through the allochthonous processes, because in the catchment areas we have a lot of carbonates and the gypsums also. So it is quite possible that we can receive this calcium, sulfur from that from the terrestrial environments also. But because we didn't have done the isotopic analysis of this gypsums minerals, so we are not able to actually distinguish whether it is from the terrestrial or whether it has been precipitated or whether it has been formed through the diagenetic processes. So based on this all results, we have found the cyclicity in the lake records, and we also find that the lake records is the potential records through which analyzing the several proxies like biomarkers and the climate isotopes and strontium neodymium isotopes, we can establish the hydroclimatic conditions in the region. So thank you, Nicholas. This was my talk.
Okay, thank you very much, Danish. I open the podium for questions from the audience. Feel free to just ask.
Yeah.
No questions? Yeah, go ahead, go ahead.
Hi, thank you for the talk. I wonder, you performed an end member modeling on your data. How did you decide what are the end members? So you have from the results the different end members, but how do you know which one is representing which process?
So yeah, let me just go back to the. Okay. So basically, so basically, we have found this end member values. For example, EM1, we have found this mostly between the 6 to 10, and this is this is scale in the 5 scale. So if you convert it this one, so it will show you this 10 between 6 to 10. It means it is the mostly the clay particles there. Then we will have this EM2, which is again between the 4 to 6. So we are corroborating this for the silt particles. And then we have the EM3 and EM4. So that is again the coarse silt to the very sand. So when we say the clay, silt, and sand, so basically we can collaborate that the clay particles mostly and silt particles, they are mostly transporting through this riverine fluxes and also through the suspension activity. But this coarse grain size, they could also comes from the riverine fluxes. But because given the scenario of this the tectonic settings of the basins, we suspect that it could also comes from the tectonic activity, due to the tectonic activity. But yeah, as for your questions, because this AMA analysis, they are actually able to unmix the signatures, but it is always very difficult to assign what is particularly controlling, because for example, this river could supply both the this coarse grain, the
Yeah.
fine grain, and between the silt also. So, but as people are doing right now, adopting these exercises, so I just follow that part only.
Okay.
Yeah.
More questions? I will ask a question. Do you think you can find seismites in the record? And if you think that you can find them, how you will find them?
Seismic record. So basically, there is what I observed in the lake, particularly the core of the samples for photography in the core samples particularly. So there is sudden changes in the sediments grain size. I observed. So we was corroborating those sudden changes to some kind of the activity, tectonic activity there. I don't have the picture right now, but we observed it, and particularly in ERK3 core.
You say grain size.
Yes. So there is sudden changes in the grain size distribution.
Okay. Well, if no further questions from the audience, I guess that you understood everything, or you were sleeping, or otherwise, you're very afraid to ask, or everything together. Okay. Well, I guess that we can close the event for today and see you next week then. Thanks.
Thank you very much.
Thank
Bye.
you. Thank you.
Bye. Thank you,
Bye-bye.
Dan. Have a good day.